If in the previous video I used the words "and finally," that was by error. I meant 16.4 is "and finally," and this is the idea of a class template, and this begins on page 1015. If we could create a function template whereby we can pass parameters of any type to a generic template and receive back the data type that we passed, so thereby not having to overload a function. Remember, overloading is a function with the same name that takes a different set of parameters. A class template is the same thing, whereby we create a class of a generic type, and depending on what kind of parameters it is that we pass to, or what kind of parameters it is that we accept for that class, that we build a class based on that parameter type. So here, I wanted to walk really quickly through this idea of a simple vector. Remember, again, a vector is like an array, only it does not have a hard number of elements that is coded at the time that we create our array. So a vector is an array that can be sized infinitely. And remember, we would do that using pushback and popback. So here we have the extra line here is line number 9. We are saying that class simple vector is really a template class. And instead of using int or double or string or whatever it is that we're going to do to manage this vector with a type, we're simply going to refer to those types as t. So what would that look like? Here, t, we have a pointer, so that is the pointer for the allocated array. We have an array size because we're going to need that int to be able to figure out just how big our vector is. And we have memory allocation errors here. This is just in case we have declared these as a dynamic array, or if we have forgotten to declare it as new. So if we go through and have a destructor for an inherited object, we're not going to destroy this particular simple vector. So that's why you're seeing those here. We're just adding all that functionality from chapters essentially 11, 12, and 13 here that we kind of glossed over for the rest of 16. So here is our constructor. You'll notice it is empty, and we just have an array pointer that goes to wherever that array is. There is the constructor with the int for how large our vector is going to be. And as we come back down through here is, allocating for the size of our vector, yada, yada, yada. And as we continue down, you'll notice that we are still using our template class in front of all of our function declarations and our function definitions here. There we go. This really doesn't work as well as I would hope. So that we can, well, here we are going to throw an exception should we need to. The interesting bit comes here. We are going to follow through with this in the code sample. This is just the setup for that. So here we are reading values into our vector, and those values are going to be ints, and you can see here that we are getting int values out. Here we are reading doubles into our vector, and here we are getting double values out. So the template class here has essentially prevented us from having to write two different class definitions, one for an integer vector and the other for a double vector. And just as you may have guessed, I'm just going to allude to it here and allow you to continue down, that they inherit down the hierarchy in the exact same way as regular classes do. So if you have two template classes, we'll call one, class A, and the other class B, which inherits from class A, you still have access to the member functions from your parent class template class entities, which is fantastic.